So who actually has heard of Ultimate Frisbee before? See, some of them know this. Okay. So today, Adam and me, Marc, will present an ultimate tactical dashboard. But before we will present our product, I will give you a short introduction into the sport of Ultimate Frisbee for all the people who have never heard this term before. Then we will explain our business mission, so a short summary of our problem we wanted to solve. Then you will see the product itself in a short demo. And finally, some technical insights, how we solved our problem. So what is Ultimate Frisbee? Ultimate Frisbee is a team sport that is played on a grass pitch, as you see here. And in one game, two teams compete against each other. So what you see here is a black and a white team lined up in their end zone. So a game consists of 14 players separated into teams. You have two referees dressed up in orange here on the image. Then the pitch itself is split into the mid part and two end zones, one here in the bottom and one there on the top. And you have one disc shown here, which is the tool you play with. So how you score a point in this game? You basically need to transfer the disc from one side to the other by passing to other players and catch it in the opposite end zone. And the most important rule is the guy who has the disc is not allowed to move with the disc. So this is the whole magic of the game. So after some theory, here you see a practical match. This is the beginning. So what you see here is the start. The white player has thrown the disc to the other part, to the other side of the pitch. And this player picked it up. And once he picked up the disc, the game starts. A quick insight into the game itself, just a historical outline of how Ultimate Frisbee was developed. It was invented in 1968 by Joel Silver in the US. And I'm not sure if someone of you knows Joel Silver before. Is there someone who has heard the name before? No, because he's actually quite famous. After he graduated from school, he became a movie producer and made the Matrix movies. So very funny coincidence. In 1975, the first tournament took place. Then in 1983, the first World Championship in Ultimate Frisbee was organized. In 2001, they became part of the World Games. It's a series of sports which are not Olympic yet, but aim for. And that is actually the next big goal of the Ultimate Frisbee community. They want to become an Olympic sport, and they already applied, but it's a very bureaucratic process. It will take a long time. So it's not yet sure when this or if it actually will happen. Right now, we have 100,000 active players in the US. And in Germany, we have a community of around 10,000 active players. Okay, so after learning a little bit about Ultimate Frisbee, what was the problem we wanted to solve? So as Jose said, in most sport, a very important tool is a so-called tactical board. You use it to, as a coach of a team, for example, to explain a strategy to your team members or to discuss mistakes you made in previous games. And you try to improve your skills by using those. And you have tactical boards for football or soccer, highly developed, but not for Ultimate Frisbee. There's just one app we found online. It's called Stato. And it's a tiny mobile app where you can basically line out strategies by tapping on the screen and giving instructions or explaining to other people by using this. And the big problem we discovered is it's really tedious to do that. Like, for example, to show this strategy, you would have to point 1, 2, 3, 4, 5, 6, 7, 8 times on the screen to model the path the disk went. And But this is a task you can easily automate if you have video footage of a game. And that was actually our project. So we wanted to build a program that can input a video feed and will output a tactical board for the given video. And now we will have a quick demo of our product.
Yeah, here is the web app. Just before the presentation, I uploaded a video so that the website can start processing it in the background. So here we have the video is already uploaded, and we can see here there is the video clip, and here's the tactical dashboard. And when we start, they will be playing in sync. So let's have a look. Yeah, we can see the players running against each other, and the dots are showing the positions of the players. And we can pause, we can fast forward, and it will move. It will move to the position that is indicated here. And the cool thing is that actually, apart from that, we can also use the toolbox to actually the coaches that are going to use this tool can, for example, say that, okay, that was a situation, and for example, here they can mark specific elements of the game. So yeah, this is what the website looks like. So first we have a look at the architecture of the web application. So it's hosted on Google Cloud. It consists of the web app, and the web app is written in Python and uses Flask for the APIs. It also uses Celery for the background worker. So basically, the web where we upload the video, it dispatches a background task to Celery, which does the processing with a library called Ultralytics. And Flask and Celery use Redis to exchange the data and manage the status. And on the client side, the web frontend is written in JavaScript, CSS, and HTML. So that rendering of the tactical board that we saw, it's done entirely in user's browser. Okay, now the machine learning part. So we have used YOLO, actually similarly to the second presentation that you saw earlier about the ship-to-ship transfers. So YOLO is a kind of convolutional network, a neural network that can be seen as an improvement over region-based CNN that was used for object detection before. And YOLO has distinctive characteristics is that it's trying to do the predictions in one pass. So it's looking at the image once, and it's trying to detect all the objects from all known classes in one pass. Therefore, the name, you only look once. So the model has to be trained. And to train the model, we used for video footage for 4 different games, and we handpicked 200 images from these matches, and we labeled them. And that was our training and validation set. And labeling consisted of saying what are the objects in the there on the image, for example, player, referee, Frisbee disc, and landmarks on the field, and what are the bounding boxes around these objects. And for the test data set, we used 40 label test images then to do our benchmark. Now, the first problem, people and disk detection. So the 3 challenges that we faced here was to distinguish between players and referees. They are basically have different colors. And but yeah, in each game, those colors can differ. Second, disk detection. So the Frisbee disk is usually very small, and on some images, it can hardly be seen. And third, we can also see that there are people standing on the sidelines of the field who are spectators, but they are not players. So also the model somehow had to be trained to disregard them. And another thing that we had to detect is the field outline, because ultimately we would like to remove the perspective from the tactical board. And for that, we identified 13 landmarks on the pitch. And those first we tried an approach that is an algorithm that is called pose estimation that is also part of the YOLO suite, but it didn't work well, probably because most of the time you can also see some of these key points on any given frame because the camera moves. So in the end, we use object detection, which is the similar approach that we use for player detection. Yeah, so here we can see the list of those landmarks that we used. Okay, so then we run training. We run the training for 200 epochs, and the results in the end were quite okay. By quite okay, I mean detection of people, detection of persons was pretty good. I think the accuracy was, I mean, the mean precision was something like 90%. And that was pretty good. And even the model learned to disregard the spectators on the edges and to detect referees. With Frisbee, it wasn't that good. Actually, Frisbee most of the time was confused with the background. So yeah, it didn't do very well. We also tried to do a transfer learning with COCO dataset, which is a pre-trained model that was trained on some number of images, and it also was trained on 200 Frisbee disk images, but it didn't help much, most likely because those Frisbee disks were much bigger or they were used in other situations. And in our situation, this disk was just small. And the key point detection look a bit so-so. So for during training, it looked okay, but we can see that in test data, there were lots of confusion, usually pairwise. Usually certain pairs of key points were confused with each other because they were quite similar. So with these key points being confused, actually, we still found a way how to proceed because we could just have a look a few images before, a few video frames before, because just to work around the problem that we not always have enough. And then how we generated this bird's eye view and tactical map. So for every frame, we had to select 4 best fitting landmarks. Sometimes we had to go a bit back to have the 4 key points. Usually they were forming a trapezoid. Then we knew the real coordinates of these key points. And for that, we were calculating a transformation matrix called homography matrix. And having that, we could already map all pixels on the target space. So yeah, this ends the technical and insights part. So to sum up, we managed to build a tactical dashboard that was able to play and update a tactical board in sync with the video. We could see that we were able to detect that. What didn't go so well was the Frisbee detection. It was just too small and we couldn't really detect it. Also, sometimes there were corner cases with the key points and perspective removal because sometimes the camera moves to one corner and then we don't have enough points to make the right transformation to remove the perspective. And also from practical terms for hosting the web app, to use this in a real production, because this solution could be used in conjunction with other applications that are calculating statistics for Frisbee. For example, instead of doing this manually, we could just feed that in. But in order to make it such product, what would be important is the cost of cloud computing, because online video analysis, it requires quite much power. We had to use high definition images. So actually, yeah, computing power can cost. And yeah, this brings me to the end of the presentation. Thank you very much.